So I'd like to welcome you all today to this short webinar on masonry panel design. It's earmarked for an hour, but I hopefully will get through it a lot quicker than that, and we'll answer questions at the end. Joining me here will be my colleague Andras Herbe. He's not quite joined in yet. He was doing something there before lunchtime, so hopefully he'll be able to hook in and answer your questions. If not, I'll look after them. So you have a little control panel. You can ask questions by typing them into the control panel. You don't get to talk to me directly. It's sit and listen and watch. If you have questions, just pop them in and we will either look at them now or at a later stage. This session will be hopefully recorded. It says it is being recorded, which is always a good sign. And we'll post it up on the website at a later date. So, my name's Tommy White. I am heading up the sales team here at the MasterSeries. I've been here for quite a long time, and I'm quite familiar with the masonry design panel. So just a wee quick overview of masonry design. So we have a massive range of products. You will all probably be familiar with things like the Building Design Suite or the PowerPad Plus, and even the Masterport. These are suites of programs that we produce. But behind that are the modules themselves, the frame analysis, the portals, simple beams. So the portals will go into the Masterport Plus. The frames will go into both these two. And then we have our add-ons, our advanced analysis tools, so our wind analysis, our BIM integration with Tekla, with IFC, with Revit, all very, very fancy. And then we have our very advanced finite element analysis, dynamic and seismic, and these are sort of very specialized programs. And we separate them out because you only take what you need, you don't take everything. So I'm just going to drop your hands there for a second. That's great. And then we have the main design components. We have our steel, concrete, our flat slabs, our FE slabs, our composite beams, our connections, and even timber design. All of these link into these frames, these portals, these beams, and are integrated and automatically seamlessly work through with them. And that's great and fantastic. But we also then have a short range of standalone programs. Now, it's not correct to say the PileCap standalone. PileCap now does integrate with these programs for more efficient design. But the one we're interested in is the masonry design. And to be honest, if masonry is all we're interested in, that's all we need to buy. And I'll mention it now and I'll mention it later. We now offer both traditional perpetual licenses, where you buy the software license and then you pay a small fee every year to get updates. Or we now offer, as well as that, either annual or quarterly subscription, which is a lot less money, but as soon as you stop paying, it stops working. It's just like AutoCAD and other packages. You have the choice, and we'll talk about that later on. So I'm just going to go back to the MasterSeries and go into the products, and we'll see a summarized list of these different products, and I'm interested in masonry. So let's have a quick look at the masonry. And what we'll see is we can do some fancy things. And feature-wise, we can do stiffened, unstiffened, load-bearing, piers, in-plane, out-of-plane, bed reinforcement, and we can design to British and Eurocode, and also historically the Irish codes, but certainly the Eurocode and the British standards. And for the Eurocode, we have full national annex implementation for all of these European countries. If you're not listed here, you can either work with the UK or the Eurocode default values, or you can go in and edit and create your own national annex. Very useful. We will also talk a tiny wee bit about the PowerPad. PowerPad as one of our suites, and it includes a small version of the masonry. So for example, in the power pad version of masonry, you don't get 10 openings. You don't get wind posts or bed reinforcement. And you don't get advanced yield line analysis. You get the simple codified formulas for designing panels with fixed and pinned supports. So without any further talking, I'm going to start up the Master Series. I believe there's a new version out, I think in the last day or so. And I'm going to log into MasterSeries because I'm on a multi-user advanced license. If I was just masonry in its own, straight in. Wouldn't even ask this question. So it's just doing its check to a cloud license. So this license can be shared. You can have 10 PCs with the software installed, but only one license, and every time somebody starts the software, it will go and check to see if that license is available. And that works not just inside an office, but anywhere in the world. Probably not China or North Korea, but anywhere you can get full internet access, you will have the software. And I've just clicked on the wrong button here. I apologize. Just bear with me as we go and look at a basic house and then come back out again. Just before this, I was talking to somebody about wind analysis, but yeah. So back out of that. Here we go. So demo walls is the one I want to look at. And we're going to take this slowly and build it up, but naturally we want to show you some impressive stuff as well. So what we've got here is a wall with a door, small window, large window. No support here but a return up here. We've got point loads and line loads from a roof, and we've also got a wind post, and we've got different fixity conditions on this, and we can design that, but we're just going to take this one stage at a time and build you up slowly. So we're going to get to something like this eventually. So the first joint wall is a simple laterally loaded wall, and you'll notice that there was a time lag there in loading the image, and that's because in the background it's doing all these calculations to work out where the yield lines come from. And if I look at this, it's on a course. If I went for a medium density yield line, these will get a little more intense, and it'll take up to 4 or 5 seconds for it to do the calculation because it's getting really down to the nitty-gritties. And if I went to fine, it could take about 30 seconds, and super fine maybe 2-3 minutes. We normally just need to stay with coarse or medium. And what I'll do is I'll turn off the auto solve so that it'll only solve when I wanted to do so, because that just gives me a wee bit of control over what's displayed. So what we've got is a wall we've set up 5 meters by 3.25 meters. Let's make it 3.5 meters. And it is 100mm inner leaf and 102.5 outer leaf. Standard UK 4 inches for the clay bricks and 100mm for the metric. Sorry, the metric internal concrete blocks. And we'll look at this in a wee while. We'll not worry about anything else here. We'll look at the edges, and the edges are set to be pinned except for the base is fully fixed. Now, whether the base is fixed or pinned is very much dependent on the construction, like everything else. If we were looking at a first floor panel, we could argue that, ground to first, first to second, it's continuous. So therefore it's continuous. If we were dealing with a first floor and we had the outer leaf supported on a shelf angle, the outer leaf will be pinned, but the inner leaf may still be continuous, the way it's bedded onto the floors. And therefore, if one face is continuous, you would normally consider both to be continuous. Basically, the rule is to do with the thicknesses and stiffnesses. If the thicker is continuous, then it's just continuous. It's very simple. So we don't need to worry about inner and outer. We could go and change it such that we have inner and outer leaf fixity separate, but we don't need to, because the rules normally allow us to work with that. So I'm going to stay fixed in the base, but I'm failing here when I solve. So if I go analyze, I will see that I have a failure of 1.14. So 14% overstressed. So I need to do a couple of things. I need to either decide that one of these at least is fixed, close, analyze, and that should give us that. It works, 0.965. So that's less than 1. But it's still blue over here on the left hand side. And why is that blue? It's very, very simple, guys. If we get a value closer to 1 than 0.9, we always suggest you go for a more detailed mesh. So it's a bit like finite elements. So we're at 0.965. If I go down to medium and analyze, you will see it's taking a second or two. We're from 9.6 to 9.8, so we're getting closer and closer to 1. And I would probably be happy with that, but if I wanted to, fine, and analyze, it's going to take maybe 30 seconds here. Enough time for me to have a wee quick sip of my coffee. So we're just counting down here, because it's looking at all the different ways that the yield lines can form and finding the weakest, I think that's called the upper bound solution. So we're at 30 seconds and we're still going. And we should be nearly there at 45 seconds. So normally I don't recommend people go for fine or even super fine until we get there. And you'll see between medium and fine there was nothing, no change. 986, I believe it was 986. Now the beauty is that it'll remember the previous 983, so it's moved by 0.3%. So I'd be happy at that. That's fine. That's going to work. So I'm good for that. Now the alternative, if that's failing, is if we can't make this fixed, is to either thicken the blocks or strengthen the blocks. Very straightforward. You've got to make it stiffer, you've got to make it stronger. Stiffer with restraints, stiffer with thickness, or stronger with strength. So let's look at the masonry. What have we got? Concrete blocks. Yeah? 10 Newton blocks. Sounds about right. If I go up to 17.5 Newton blocks and then look at the outer leaf, clay, and we're going to go for 7 to 14. We're going to go for the low absorption. That always gives us a stronger block. And And clay bricks 15 is a pretty common value. So if we come out of that now, and again I haven't auto solve turned on, so you just have to hit the analysis, and I should find a significant improvement in that strength without having to go for thicker blocks. And there we go, we've gone from 0.96 or 98, whatever it was, down to 0.86. So we've got about a 10% improvement in strength. A considerable increase in the strength of the blocks, but not a very significant increase in the flexural strength, not a very significant increase in the lateral load. And our lateral load is 1 kilonewton per meter squared. Pretty typical wind analysis, and certainly in the lower regions and Midlands. Up in Scotland, I was playing with a guy there earlier, looking at wind analysis, and we were in where was it? Islay, and we were at 3.5 kilonewtons a meter square. It was a bit scary. So that works. Now let's look at the next wall. And this next wall introduces something that's actually going to improve the strength of the wall and make it worse at the same time. And that is loading from above. Now, these are point loads. We'll deal with them separately in a minute. These are wall loads. So the inner wall, we have a concentric load from above, from a roof and a wall, and we have an eccentric load from this level. It shows it on this side. It would probably be more realistic be on that side. It doesn't really matter from an analysis point of view, but that is the eccentric loading from the loading at this level, such as the floor and the live load on the floor. And then the outer leaf has just the self weight of that upper leaf. And yes, in our first wall we were still taking the self weight of the wall itself. Of course we were. It was one of the inputs. So we can see when we go analyze whether this works. So we can see where we're improving our flexural strength with the GD value and the gamma and everything, and we're getting up to 0.58 as our flexural strength from 0.35. That's an improvement due to that pre-compression. So now if we look down, it's still failing, but it's not failing on flexural strength. The flexural strength is 0.7. What it's failing on is the point loads, not the line load but the point load. So the bearing stress under that point load is not happy. So let's go and look at these line loads. So first one was the easiest, was the concentric and eccentric linear loads on the top of the wall, and that's fine. The second one was the point loads, and we got 2 point loads of 15 and 5, and they're at 1.75 and 3 meters apart. So we could even move that if you wanted to 3.5. That's not going to affect the bearing because that's still doing it by calculation. I'm going to say the bearing width of the member. And if we look at the diagram, BW is how far into the wall it bears, and I'm going to say it's going to be 50 mil in, which is going to give it a 25 mil eccentricity. And I'm then going to say that it's spread out over, actually it's this value here, B len. B len is the length of the pressure, and that's going to be from a 203, 133 or 122 or something, so I'm not sure. So I'll put 125 mil width there. But what we don't have is a footing, as a pad stone. So I'm going to put in a standard stone brick, 215 wide by 75 deep. So if you slip in what I would call an engineering brick, a high compressive strength brick, and do the calcs, we do not then need to create a specific pad stone. We will get away with a single brick or 2 bricks if you want to, depends on where the point load comes down, onto that of an engineering brick class, and that will solve the distribution of stresses. We're also looking at the additional buckling from these as we come down, the buckling cases and the buckling loads over an average of 1 meter coming down over through that. So it's taking all that into account. So if we had overlapping point loads, we would have even more onus on one area of that. And it is very, very straightforward. And I see my dear friend Andras has arrived. Welcome. So he should hopefully be starting to answer any of those questions that have come through. So that's vertical loading, line loads and point loads. Very powerful, very useful. Plus our lateral load. So let's move forward and move forward to our third type of wall, which is the freestanding wall. It's actually the one I hate because there's so many walls standing that don't work to the codes of practice, because our load factors and our gammas on our materials are so stringent. If we look at this wall, it's 1.8 high. We're failing by 25%. So our piers are 3 meter centers. I could pull those closer by 25-30% and get it to work. Or I can make them bigger, or I can make this thicker, or I can try and improve the strength of the wall. So if I went to masonry, 17 Newton blocks, you're not going to get any stronger in blocks than that. Even 10 Newton blocks will probably give you a very similar answer, because you've hit that threshold of not giving you any more flexural strength anyway. So how am I going to solve this? I'm going to solve this by pulling the piers together. So, wall setup. Center to center is 3 meters. I'm going to make it 2.750 and move away. And it's on auto design for this. And if I reanalyze, it's still failing at that distance apart. So I possibly need them pulled into 2.4 meters. And here it goes, recalculating, and we're nearly there. So in essence, we probably need a wall that's not 1800 high in this location. We need either a thicker wall or a smaller wall. And if I was to come along and say it's not 8.8, but 0.65, take 6 inches off it, the architect will never notice. It's recalculating, and we're there, but we'd need to do a more accurate analysis. But in this case we don't, because the U line is perfectly a single line across the bottom, so there's no benefit in going to finer meshes anyway on that. So that is a little sidestep into freestanding walls. You know, without the piers, they're not very happy at all without getting quite large. Now, let's move into the more exciting things. Columns. Yes, this is not a cavity. This is the two different views of the same column, and likewise the two different views, the X and the Z view of this column. And what we've got are point loads that are eccentric. So if I look at my vertical loads, I will see it knows it's a column, so therefore it's giving me the basic loads, the concentric loads, that's the green ones, and then the eccentric loads are going to be that and that. Now it could be that we could argue that it's only 20 in each direction, and we're happy with that, and we just close that down, reanalyze, and it tells us that we're failing. So solutions. Now this is a compression problem, so that screams out for stronger. So let's go to 17, and it works. Doesn't need U-line analysis, so the answer is instantaneous. Interestingly, we take all the UK values and some of the other European values in here by default. You can go in and put in your own values of axial and flexural strength, and you can even add in your own bond values if you want to modify the values to be your own custom blocks. And just one check here. Yes, we are working to the Eurocode. I was just checking that for a second. So that's columns, very simple, very useful. And then we move into the bane of everybody's life, openings. Now, I have two ways of doing this. If I only have the PowerPad version, I would then be working with only up to 2 openings, and I would be creating little sub-panels to distribute this all about. And it's given me all my sub-panels, and they're failing absolutely miserably. So sub-panels can work sometimes, but not usually. The yield line analysis is going to give me a failure. It's only 1.5, not 3.5. That's a lot better to start off with. So how am I going to improve that? Again, stiffness and strength. Stiffness of the edges might help, and strength of the walls. Let's look at the walls first. So let's look at our masonry units. Concrete blocks, 10.4, that's about as far as we can go. And the masonry is 10 Newton blocks. That's standard, and I'm not going to go any further than those. So I'm happy with the strength of the wall, of the blocks and the brick. Mortar we can play around with, but most people don't understand what they're doing, so they just leave it alone. And M2 is your standard classic mortar. Fixities, well, if we were to, sorry, wrong button, fixities, if we were to make the 2 edges fully fixed, it's having a jolly good think. We're down to still 3-4% overstressed, so that's not very good. So I'm going to go back to pinned and pinned and close that. Now let's look at the next wall, which should be this one with a bit of a solution if I remember right. No, it's not. I actually don't remember my own order, so I'm going to have to fix this, and I'm going to fix this by one of 3 methods. Either the very slick method of putting in rebar, and we're going to go for inner reinforcement. I'm going to choose it from the library, and we're going to use the Beckhart Muir 4. We also have the others, or we can specify our own, not from library, and put in our own yield stresses and everything. So it's an internal 50 on a 100 thick wall. That makes sense. And every 225, every other brick course makes sense, or every 3rd brick course in fact. And I just close that down. And that is getting us a bit of a strength improvement, but not everything. So we can go back out to rebar, and we could add in external reinforcement. Now external reinforcement really gives you a lot of grief. So even if I went from Euro 4 compact, I would need to go for the external 35. So the bars are only 35 mil apart, which is giving it 30 mil cover basically, because it's external. Now if you were rendered, you could get away with less cover. You could probably use the i50 instead of i20 E35. So again 225, and it's not doing enough for us. Now naturally we could, particularly in this one, come down and go for 75, so every brick course, and see if that strengthens it enough. And it's bringing us down to nearly working at 0.967, and of course you would probably turn around and say put those in every course as well. Quite onerous, having bed reinforcement in every level. Quite expensive. The alternative, if I turn off bed reinforcement, and it's the auto design I didn't turn off, auto solve I didn't turn off, and I'll just turn that off in a second. The alternative is to put a pier or a wind post. So let's do the old-fashioned pier. We can come along to wall setup. We can ask it for it to be stiffened. And in this case I've actually got a pier over here, which is not what we want. I want a pier in the middle, and it's not going to be that size, so I'm going to drop that out. Make it 1, 2, 2.5, so 2500. And I'm not going to make it 450 for the pier. I'm going to make it 215. Well, maybe 225 in fact. And there we go, a nice wee pier. It's improved it slightly, but not by a lot. We're going to need a large pier to really stiffen this up, and that's not how we want to go. So I'm going to say nope, don't like piers as stiffened wall. I'm going to choose the wind posts instead. So I'm going to put this wind post at 2.5, and we're going to add it in as a steel section. Here we go. Now I'm going to choose a hollow section, a rectangular hollow section, and I'm going to choose something small, such as a 100 by 60 by 3 by 6.3, and apply. Now that is going to then need to be considered. And how is it going to be considered? It's going to be simply supported top and bottom, and it's going to be considered not to break the inner leaf, but to be actually sitting in the cavity or out here. It doesn't matter where, it's just attached to it, so it does not break the inner leaf. And I now have a solution that's giving me 0.558. So chopping it right down with that one wind post, 100 by 60. Now that's 100 in the major axis. I would probably actually take that and move it about its minor axis. So it's a minor axis, so it's not as strong, and it's thin enough at 60 mil to fit into the cavity and be mounted in the cavity and shot fire. You know, the masonry would be shot fired to attach it to it. and that's a good solution. Now, let's analyze that. The one question we get asked about with our wind posts is, what about the design of the wind post? In essence, there is no design of the wind post, because the wind post is absorbed into the masonry as a stiffness and a strength. So it's implicitly checked as fully restrained in the yield line. So what I'm seeing here from this is that we're coming along down here with this vertical yield line. So the green lines are what you would call hugging, and the blue ones are what you'd call sagging. So blue ones middle of the span, sagging. Green ones at supports. And you'll see that it's acting as a support because the yield line is running along the member. If I went back to that wind post and I really dropped its size down to, say, a 50 by 30 by 5, we might see now that the yield line of the masonry just goes straight through it, but at a better value than when it wasn't there. So it's stiffening this up, but the yield line is still there. So in essence, at failure, it has actually yielded through this member. So if I was to come back to this and change it up ever so slightly, say to a 60 by 40, we will see now that the wall works with the theoretical yielding being straight through the column, the wind post, but it's fine. The post is doing its job and everything is fine. It's implicitly checked. Personally, my own opinion is that while that's theoretical and analytically correct, I prefer to see the yield lines going the other direction, where it's actually working as a support rather than just a stiffer part of the member. That's easy enough to get by just increasing your section size. So that's your wind posts and your bed reinforcement and your piers, all done on the frame. We actually can do more than that. Those would cover your general facilities and features that you want. What we have here is a wind panel that has a wind loading plus a 1 kilonewton meter surge load, a horizontal line load, pushing against that. So some sort of barrier or something, or attachments for racking in a warehouse can be made. And the question was, well, Tommy, how do you do it if you only want a couple of point loads horizontally pushing onto the wall? Well, pardon the pun, but that's just a wee bit of lateral thinking. So let's go to these line loads. And I'm going to put the first load in, and I'm going to have it starting at 1 meter out. In fact, I'm going to have it starting at 0.95, and it's going to end at 1.05. I'll just quickly turn off the, I'll turn off the auto solve for a second, just so I can get my information in here a lot easier. Line loads. So 0.95, and it's going to be 1.05. So 100 millimeters. We're going to lift it up to being at 2 meters up and 2 meters up. So it's going to be up there. There it is. But it's only over 100 mil, so I want to magnify its intensity up by a factor of 10. So if I wanted a 1 kilonewton, I would put it in as 10. And I can then do the same 10 and 2.95, 2, 2, and 3.05. And there we go, 2 horizontal point loads on the panel. So when I close it, and then I go analyze, and it will now do the analysis with those 2 point loads. And it's been attracted, even though it's supported the same all the way around, it's been attracted to where these point loads are to give you more, and it's failing miserably. And obviously bed reinforcement, thicker walls, stiffening, all that are the solutions to solve that. So yes, we can put lateral loads onto the wall, point loads, just by using a wee bit of ingenuity, because in reality no point load is going to be a point, it's going to be some sort of finite length, and 100 mil is as good as any with regard to brickwork, because a brick's never shorter than the 100 mil anyway. So the last thing I want to look at is coming back to these, but this is like a freestanding, as a wall, say in a car park, that's fixed into the columns at either side and the base, and it's got a 5 kilonewton per meter surge load onto it, plus a bit of wind, and they're always assumed to be going in the same direction, by the way. And we will see that we need to just do our solution. And we'll see that we're failing 1.9. So we're going to need to go up by about another half in the thickness, 300 mil wall. Doesn't sound great. What we can do is to go back to wind posts and add a wind post in it, 2.5 meters. And for a 215 wall, I'm going to choose a UB, or I could choose a channel. That is 254. And we'll just choose the lightest. So we'll sit just slightly proud either side and apply. Now what I'm going to tell it is it's fixed at the base and it's free at the top. It's a cantilever. And I close down and I reanalyze. And that now works. So we can get away with this wall having a little fixed wind post in the middle to break up the very large span of the freestanding wall to allow for a surge load onto it. And that is quite a clever little tool. And do I have another one? I don't think so. I think I'm back. Yeah, I'm back to the start. So that is everything that I wanted to show you. I said it would be around 40-45 minutes. So I'm just going to look at some of the questions and we quick at some of them and see if there's any I can answer for you. If I can't, if I need to get a detailed answer, it'll be in the email we send you afterwards. What about the bottom fixity when we have a DPC? Well, that's a very good question, and it's one of those eternal engineering questions. Most DPCs will give you a shear resistance, absolutely. So at the worst, we should be able to consider it to be simply supported at the base. And that can be done in this example here. We can do that very straightforward by going to edges base and going pinned. I wouldn't go for free. And that's detrimental to that design, but it's still working with this wind post and the pier on this side, the dirty big return pier we put in here, much to the architect's annoyance. There are DPCs that state that they do give you full strength through them. Also, as I had mentioned earlier, the use of 1 or 2 courses of engineering brick instead of a DPC works very, very well. The very high strength clay bricks look nice architecturally, marking out the bottom of the wall, but they also usually provide a reasonable degree of prevention of water ingress. And if we're on an upper floor, then it's a more clear cut. Is it on a sill or is it just continuous? On you go. You don't need to use the normalized block strength, so not 10.4 but equivalent. We actually do use the equivalent values for those normalized ones. And that brings me to another interesting thing, a difference between the Eurocodes and the British standards. If I was to go and change, let's go for my second wall, it's a simpler wall to work with. If I was to come along and for whatever reason go back to BS, and we'll just do an autosave, it'll not take long. And this is having me think, and it's at 0.894. So the blocks, and what is my analysis method? It's medium. Let's just go for coarse. It'll just be a bit quicker and it'll give us more or less the same answers. Yeah, slightly less, but 2% difference. If we look at the masonry unit when we're in British standards, we have the facility to say whether it's a hollow block. So concrete block, hollow block, solid block, or hollow block with in situ. When you're in the Eurocode, you then just have to go in and override the strength with the normalized value for your blocks. So if I'm to come out of that, so I can do that change. If I go back to design codes, BS, over to Eurocode in 1996. If I look at masonry units, there is no type, there is no hollow blocks. You have the strength, we're actually using the normalized mean strength in reality, so you can come in and put in your own value there if it's a hollow block that's not filled and such. So interesting. It's a question I get all the time about normalization and also hollow blocks. Can you input negative loads in to represent wind uplift? Not really. Simple answer is no. I would not think that it would actually be of any interest. If I was to turn around, let's try it, and go to my, just get rid of my 2-point loads for a start. Delete. And delete. Right. And I don't think there's any in the outer leaf. No, there's not. So we're just in our wall loads, and you want to put, for whatever reason, let's make them concentric only. And we're going to say that it's -1 And well, let's look at our value, 0.948. If I had to put that in at minus, let's be stupid, 50. It's certainly checking it and finding that we're getting a tensile stress above. So maybe there's some, and if I change that from minus 50 to minus 5, does that stress improve? It does. So I wouldn't do it, but yeah, you can. Good luck to you. Because normally your other loads are worse. Yes, occasionally if you're doing a garage or something on a flat timber roof, you could have uplifts that are higher than any self weights of the roof and everything. So yeah, why not? Do we get to access the video afterwards? Absolutely, Kenneth. That's what I will be doing next. What load combinations are considered, both permanent and everything? Yes, we are doing it, and we are looking at your load combinations. Now, there is a little note here. It's not a big problem here, everything's fine. But when you're in your wall loads, you want to see whether or not you want to have QU and QK as leading or accompanying loads. So you can look at those being leading rather than accompanying loads, and it will adjust your load factors accordingly. So you do have that facility to change that orientation, but it is checking in essence the most critical values. Will the future updates include Australian masonry standards? It isn't in our development plan at the moment, but certainly, if it was something that was commercially viable to us, let's be honest, it's something we would consider. And I suppose the first part of that will be looking at what are the differences to that. Can the piers be set at different centres? Right, that is not at this moment in time possible. What you've got in your wall setup is basically, it's not a fiddle, but you do have the ability to say where the first pier starts, which is D0. If you put that in as nothing, it's going to try and assume them to be centered. So if I put that in 5 meters apart, it's going to put half up here and a half up here at either side. If I was to put these at, say, 3 meters apart, again, it's going to center them and just try and do them equally spaced. So if D0 is nothing, it then puts them in symmetrically. If D0 is a value, that sets the start date, and then they're repetitive. So individually placed, not at this moment in time. I can understand where you have something really complicated with openings and everything, and you want to have a pier there and a pier there. Absolutely. Now, the wind posts can be done that way, just not the piers at the moment. That's a shame. So be nothing but double brick. Well, it's only tradition that we put blocks in the inside and bricks on the outside. You can have bricks in both, you can have blocks in both. It's all up to you. You can choose whatever you want to do with that situation. Is the program updated as soon as any changes are made to the relevant codes? I'm going to say yes. Obviously, we do update several times a year and we do monitor the codes, but obviously it can sometimes take a wee bit of time for that to happen. If there's a code of practice change or amendment issued, we would look at that and implement it as soon as we can, and then let everybody who has that program know that there's been a code of practice change. Now, if it's beneficial to everybody, we don't necessarily go full pelt eventually. But if it's something that's clearing up somewhere where you could actually under design something, then that's is critical, and that will be notified as soon as possible. What does place parallel with gap mean? Right, that's to do with bed reinforcement, Stephen. And let's just imagine I have a 215 wall or even thicker. Did it turn on? There we go. So I am putting one strip of Muir 4 compact. I could put 2 strips down, and then I would tell you how far apart the 2 strips are. So, I could say that it is got a 50mm gap between the 2 strips. So strip, which is 50 break, and then 50 strip with the 0. So if I look at the product data sheet, I don't know, hopefully this is still up to date. This is what we're talking about here. This is a single strip of the bed reinforcement. And that's a 70mm internal bed reinforcement on a 100mm wall. So even it's banding slightly outside, but if we're putting pair in, we'd have the second pair over here somewhere, or second strip over here, and there would be a gap between the 2. That's all that's talking about. Is the wind post also designed? As I explained, it is part of the overall solution, so it's assumed to be restrained. So we're looking at the yield line, yield stresses of that member, and if it yields and still gives strength to the wall, so it's inherently designed. How do you put leaf reinforcement at 75mm when the leaf is 215? Well, I could have been concrete bricks rather than concrete blocks, same thing, and that would have, yes, I would have had to go back and said they're concrete bricks rather than concrete blocks. You're absolutely right there, that to go less than 215 is a wee bit of an onerous, but with the right shape of bricks, it's doable. If you use a UB wind post, does it assume the post is lateral restrained? It's always assuming it's lateral restrained on the wind posts. Can you model a restraint to represent a return wall instead of a wind post? Well, return walls, I mean, the codes of practice tell you that if a return wall goes back so many thicknesses, then it's just simply support or it's continuous. Those are just basic rules in the code. But as you will remember from my own last example, or first example, I think it was actually. We did do a return here now, a thick return in this case, as a pier instead of a wind post out here, because it did not have any other support. Are we saying the wind post is still to be checked? No, it does not need to be checked, because it's part of the overall strength. What about the top and bottom fixings of the wind post? Absolutely, you're going to have to say, well, let's take this area of wind onto the post and let's design our connection for that shear, top and bottom. Absolutely, that still needs to be calculated. The way of it being yield and analysis, it's going to give you an idea of where the load's coming from, but it's not going to allow you to accurately know what the reaction is. And the simplest way to do that is to assume, half goes that way, half goes that way, unless you want to do an envelope shape and apply it yourself. Is there an option to add a proprietary wind post? Yes, you can add in user-defined properties, and what you're doing there is you're adding in and you're telling it what the yield and the moment capacity of the section is, and that's all you need. Description and what is the moment capacity of that section, because it is a plastic yield line analysis. Okay, I think that wraps it up. It's gone 2 o'clock, 5 past 2. I will look at any other questions and we will review them and answer them for you. One last person is asking, is there enough space for the wind post? Well, in essence, we don't care where it goes, whether it goes there, there, or there, provided it's fixed properly. Which is why I chose a rectangular hollow section that was lying on its minor axis so that it would fit in the cavity. But it's perfectly valid to have it in line, and you can then say whether or not it's continuous or it breaks the masonry. Now the masonry guides on fixings will tell you that most shot fired fixings into the steel and mortared up will give you full fixity of your masonry. They're far stronger than the masonry was in the first place. So normally, I say that normally, you assume it's just continuous rather than being broken and simply supported. So ladies, gentlemen, everybody, I'd like to thank you for coming. We will send you a link to the video. We will send you the questions and also the answers to those questions. And we'll also send you, for those of you who aren't users, what the current options are for either purchasing or subscribing to the software and renting it. I mean, for example, this masonry can be rented for as little as, I think it's £110 for a 3-month rental on a reoccurring basis. You can cancel at any time. There's no long-term commitment. But obviously we will answer everybody around the world with their information to look at the software. It's all run through the cloud. From a licensing point of view, you just need the internet and that's it. If you have any questions, just give me a call, Tommy at MasterSeries.com, or more generally, for technical questions, it may be better to go to help at MasterSeries.com. For any sales inquiries, just go to sales at MasterSeries.com. I will put all those email contacts into the email for you as well. I thank you all very, very much for coming. Have a good and safe day, and I look forward to speaking to you in the future. All the best now. Thank you. Goodbye.